Welcome so much, ladies and gentlemen. Our discussion today is on the wave speed formula or equation. Our objective is to apply the wave equation in calculations. Make sure you subscribe to our channel, and we shall be giving you the best videos to help you in your studies and revision. The wave equation or formula. We go straight to the formula. Velocity equals to wavelength times frequency. Using symbols, this can be written as V equals to lambda F, whereby V is the velocity, lambda stands for the wavelength, and F stands for frequency. This equation can be applied in calculations to get either velocity, wavelength, or frequency, and sometimes we can apply this indirectly to get the time period of a wave. Let's move to calculations, and we're going to do our calculations by working out some few examples. Our first example: the frequency of the sound created by a tuning fork is 165 Hz. If the speed of sound in air is 330 meters per second, calculate the wavelength of the sound waves. Solution. We can see that in the question we are provided with the frequency and the wave speed or velocity. So we're going to begin by writing down the formula or the equation, which is V equals to lambda F. This implies that, rearranging this equation, we get lambda equals to V over F. Then we substitute for V and F as follows. So we say this equals to, our velocity is 330 and our frequency is 165. So we substitute, we get 330 divided by 165, and this simplifies to 2 meters. Therefore, the wavelength of the sound waves is 2 meters. Our second example: if the speed of sound in water is 1,600 meters per second, what is the frequency of a sound wave with a wavelength of 2 meters? And our second question: determine the period of this wave. Solution. We begin with our first part, that is A, and first of all we have to write the formula, that is velocity equals to wavelength times frequency. And since we are required to get the frequency, let's make F the subject. This implies that F equals to V over lambda. So we need now to substitute for V and lambda in this equation, so that we have 1,600 divided by 2, whereby the frequency of the wave becomes 800 Hz. Part B, we are required to determine the period of this wave. Earlier, we had discussed in our tutorials and said that frequency equals to 1 over t, or the time period of a wave is equal to 1 over the frequency. So we have our frequency as 800, and so t can be expressed as 1 over 800, whereby the period becomes 0.00 125 seconds. Our example 4, the wavelength of a certain electromagnetic wave is 5 times 10 power negative 7 meters. Given that the velocity of the wave is 3.0 times 10 power 8 meters per second, what is the frequency of the wave? And B, the period of the wave. Solution. First part, we know that velocity is given by the wavelength times the frequency. Since our question is to get the frequency, then let's make f the subject. So this implies that frequency equals to the velocity over the wavelength. So we substitute for v and lambda in that formula so that we get 3.0 times 10 power 8 divided by 5 times 10 power negative 7. This simplifies to 6.0 times 10 power 14 hertz. That becomes our frequency. Question B. We have been required to determine the period of the wave, and we know that t equals to 1 over f, and we already have our f, so we substitute and get 1 over 6.0 times 10 power 14, which becomes 1.667 times 10 power negative 15 seconds. It's now your time to try out some few questions and test your understanding. Question 1. A light wave travels with the wavelength 600 nanometers. Find Roman 1, its frequency, 2, the period of the light wave. Question 2. A period of a certain wave is 0.02 seconds. Given that its wavelength is 30 centimeters, find 1, its frequency, 2, its velocity. See you in the next lesson.